Good morning, children, and welcome to today's class. In everything, give thanks, for this is the will of God in Christ Jesus concerning you. With this note, let us begin the lesson. Today, we are going to study about the electric generators and transformers. Okay, I hope you like the class. Please write the test in the classwork notebook without fail. Let us study about the generators. What are generators? Okay, they are devices which produce current. Okay, what is the working behind the generator? Usually you would have seen generators, small generators outside the shops where they use as a standby. When there is a current failure, they would start these generators which produces electricity. It provides electricity. You also must have heard about the electricity being generated in hydroelectric power station, next up in thermal electric power station, nuclear power stations. All these are places where they generate electricity. Okay, when you generate electricity, here the mechanical energy is converted into electrical energy. In an electric motor, electric energy is converted into mechanical energy. We do work using electric motor. But in electric generator, mechanical energy is converted into electrical energy. We produce energy in generators. Now, let us look at the working, or first let us look at the parts of a generator. Again, a generator consists of an armature rectangular coil which is wound on a soft iron core. This is the armature A, B, C, D, and the two free ends of the armature are connected over here to slip rings. You call these two rings as slip rings. There in an electric motor, it is connected to split rings. Here it is slip rings. Okay, these two slip rings are connected to carbon brushes and to the external circuit which receives the current, the load which receives the current. Okay, remember here we are converting mechanical energy into electrical energy. So now this armature is rotated by some mechanical means. It is rotated and in between the powerful magnet. Okay, so here this works based on electromagnetic induction. Electric generator works based on electromagnetic induction. Now this armature, this coil, rectangular coil, is placed between the poles of a strong magnet. So there is magnetic field produced due to the permanent strong magnet. Okay, so now this coil rotates between the poles of the magnet. So when it rotates, the change in the magnetic flux induces current in the coil. In the first case, if you see the current, okay, the coil rotates, AB goes up and CD goes down. Okay, so it rotates in one particular direction. Therefore, for the first cycle, what happens is current is induced in the coil. It travels through AB and comes out through CD. In the external circuit, you can see it going from B2 to B1, from B2 to B1. In the external circuit, you see the current flowing from B2 to B1. So in the first half cycle, AB current produced flows through AB and comes out through CD. So a force is experienced by the armature and it starts rotating. Do you understand? And that current is collected in the load. It is taken as output. So by mechanical means you are rotating the armature. So when the armature rotates in the magnetic field, due to the change in the magnetic flux, current is induced in the coil and that is collected outside. Okay, in the second case, you see the current flows through DC and comes out through BA. Okay, it rotates in the opposite direction. BC goes up, AB goes down. So it rotates in the opposite direction. Now the current flows from B1 to B2 in the external circuit. From B1 to B2 in the external circuit. So this is the parts of a electric generator. Okay, it consists of an armature rectangular coil wound on a soft iron core. The two free ends is connected to, what do you call this as? Slip rings. You call it as slip rings. These two slip rings are connected to carbon brushes. The carbon brushes are connected to an external load which collects the current that is produced. Okay, and electric generator works based on electromagnetic induction. So change in the magnetic flux produces current in the coil. Okay. Now again, the working of an electromagnet, you can see how it works. Are you able to see? The armature rotates. These two are the slip rings. These two are the slip rings which is connected to two carbon brushes, and the slip rings are connected to the armature. Okay, and can you see the magnetic lines of force that cuts through the coil? Okay, the change in the magnetic lines of force, what does it produce? It produces current in the coil. Okay, so this is a permanent magnet with the concave poles. Okay, these are the two, north pole and the south pole. And magnetic field induces a current. The change in the magnetic field induces current in the coil, and it is received outside. Do you follow what I have explained about the generator? Yes. Next is comparison of an AC and DC generator. Now in an AC generator, you see the armature is connected to slip rings. Armature is connected to slip rings. Here the current produces alternate current. The current produced is alternate current. In the DC generator, the armature, the rectangular coil, is connected to split rings. We call that as commutators. Split rings. Okay, commutators. Okay, and the coil, though the coil rotates in opposite direction, there is always unidirectional current. Always current flows in one direction. Okay, so therefore there is, here we use a commutator. In DC generator we use a commutator. Okay, it changes the direction of the coil, the current, but flows in one particular direction. Unidirectional current is produced using split rings, and using slip rings, okay, AC current is generated. Alternate current is generated. Okay. Next, what is a transformer? Transformer is a device which is used to convert low voltage into high voltage AC current, or high voltage into low voltage AC current. We already saw in the previous lesson. Transformers are used to convert or vary the voltage of AC current, alternate current. Either you can convert low voltage to high voltage or high voltage to low voltage. This also works based on the principle of electromagnetic induction. Let us look at the a transformer. How does a transformer look? Now this consists of soft iron core, and around the soft iron core is the coil wound. Okay, this gives you the number of turns. The first here we see the primary coil, the other side you see the secondary coil. Okay, now when the primary coil is connected to an AC power supply, when it is connected to a power supply, current flows through the coil. So when current flows through the coil, we already know there is a magnetic field produced around this coil. Now that magnetic field change in that magnetic field induces current in the next coil. Actually, secondary coil is not connected to any power supply. Do you see? It is not connected to any power supply. So, only the primary coil is connected to a power supply. So, when current flows through the coil, there is a magnetic field produced around the coil in the primary winding, this side, on the primary side, and this magnetic field, the change in the magnetic field induces current, forces current into the next secondary coil, and that helps the bulb to glow. So the output is received on the other side, on the secondary side. The input is given to the primary coil, and as current flows through the coil, a magnetic field is produced. That magnetic field, okay, induces a current in the secondary coil, and you can see the secondary coil is connected to the bulb and the bulb glows. So this is the working of a transformer. So it works based on the principle of electromagnetic induction. Okay, you can step up or step down the voltage. Either you can step up or step down the voltage. What do you mean by step up transformer? Here this transformer is used to change low, okay, AC voltage to high AC voltage. You call it a step up transformer. It converts or changes the low AC voltage to high AC voltage. That means in the outside, that is on the secondary side, the voltage is more. So on the primary side, the voltage is less. So low voltage from the primary side is increased to high voltage on the secondary side. So on the secondary side, the voltage is high. On the primary side, the voltage is less. Okay, what about the number of turns in the coil? If the voltage has to be more over here, number of turns in the primary coil is less and number of turns in the secondary coil is more. And you call this as step up transformer. You are changing low AC voltage to high AC voltage. Okay, so number of turns in the coil of the primary is less, whereas the number of turns in the secondary coil is more. Here in the secondary coil the voltage is high, here in the primary coil the voltage is less. So low voltage to high voltage, you are stepping up the voltage. What do you mean by step down transformer? In that case, what about high voltage is being reduced to low voltage? You are changing the high voltage, high AC voltage to low AC voltage. You call this as step down transformer. So what about the voltage on the secondary side? It is less. The voltage on the secondary side is less. The voltage on the primary side is more. Then look at the number of turns. The number of turns on the primary coil is more. Number of turns in the secondary coil is less. So you are converting in step down transformer. What are you doing? You are converting high voltage AC current into low voltage AC current. In step up transformer, what are we doing? We are converting low voltage AC current into high voltage AC current. So in step up transformer, the number of turns in the primary coil is less and the number of turns in the secondary coil is more. In the step down transformer, number of turns in the primary coil is more and number of turns in the secondary coil is less. So these are the two types of transformer, step up and step down transformer. Next, the formulae pertaining to the transformers. Okay, number of primary turns NP by number of secondary turns NS is equal to the primary voltage by secondary voltage. So NP by NS is equal to VP by Vs. Number of turns in the primary primary turns NP is directly proportional to the primary voltage. Number of secondary turns Ns is also directly proportional to the secondary voltage. Okay, next is the number of secondary turns Ns by Np is equal to the primary current Ip by secondary current Is. Okay, number of turns in the secondary coil Ns is directly proportional to what? It is directly proportional to the primary current Ip, and number of turns in the primary coil Np is equal to the secondary current Is. Do you understand what I am trying to explain? Yes. So, next let us see about the applications of electromagnets. Applications of electromagnets, there is so much that you can give us example. So electromagnets have created a great revolution in the field of engineering application. In many fields now we use electromagnet. Electromagnet plays a very important role in making instruments in different fields. Electromagnets have its impact. Okay. Next is, let us look at the speakers. How does a speaker work? What is the principle behind the working of a speaker? Speaker also works based on the electromagnetic induction. So in a speaker, inside a speaker, you have a permanent magnet, and in front of the permanent magnet you have an electromagnet. What is an electromagnet now? An iron can be wound with the wires that carry current, and it is connected to an external source. So when current flows through the electromagnet, this becomes a magnet. So what happens to the electromagnet? This is a permanent magnet. It remains stationary in its place. But the electromagnets, due to the what happens due to the change in the magnetic flux, it experiences a force. So this electromagnet moves forward and backward, and this electromagnet is connected to a cone made out of paper of plastic material. Now what happens is, when the vibrations that is produced, that is when the electromagnets move to and fro, move forward and backward due to the change in the magnetic flux, when current flows through the coil, what happens? It turns into a magnet. There is a magnetic field. It repels from the permanent magnet. Yes, so therefore what happens? The vibration is absorbed by the cone and it is amplified as sound. It is amplified. This vibration experienced by the cone due to the movement of the electromagnet is amplified as sound. This is how a loudspeaker works. So in a loudspeaker, what do you have? Electromagnet. Okay, so this is a permanent magnet, this is an electromagnet. So both the magnetic fields will repel each other. This is fixed, permanent in one place. So electromagnets move to and fro. It moves forward and backward. So this electromagnet is connected to a cone made out of paper. So this vibration is amplified by the cone, and that comes out as sound. Do you understand the working of a speaker? Yes? Okay. Next is, can you see the electromagnet moving forward and backward? Yes. And so the vibration is converted as you speak before the mic. Okay. When current flows through the coil, the electromagnets move forward and backward, and that vibration is absorbed by the cone and it is amplified as sound. So loudspeaker, you can hear the voice of the person who talks. Next is the magnetic levitation trains. Okay, you would have seen these trains in Japan. Okay, in Japan they use magnetic trains. So these trains travel along the guideways of the magnets only with the help of the magnets, and these magnets control the train stability and speed using the basic principles of the magnets. Okay, you can see this train traveling very fast on a suspension. like that. Okay, like this. There's a suspension, and from there they keep traveling, and it is controlled only by the magnet. So this magnetic levitation trains work based on the magnetic principles. Okay. Next, electromagnets are also used in the medicinal field. Okay, special equipments. Okay, there they use these electromagnets. Have you heard about MRI scan? Yes, this is used to scan a person. Okay, so MRI scan works based on the electromagnetic principle. Okay, magnetic resonance imaging. Okay, you get the 360 dimension of the part of the person you want to scan. So MRI scan, it is used in MRI scan. Okay, and next, for medicinal equipment such as scanners, X-ray equipments and other equipments also use the principle of electromagnetism for their functioning. Yes. Okay children, I hope you learnt about generators